Hi everyone, welcome to this interesting video tutorial on Dr. Semmelweis hand washing case study using Python. In this video, I'll make you understand how analytics is being used to solve business problems in healthcare. We'll look at a real-world case study in healthcare using Python programming. This case study dates back to the mid-19th century. We will learn how a doctor could solve a very critical problem in Europe during the 19th century by analyzing past data. So let's begin. So now we are going to look at healthcare market forecast. So as per marketsandmarkets.com, the healthcare analytics market is projected to reach 75.1 billion US dollars by 2026 from 21.1 billion US dollars in 2021. Now talking about India, as per statista.com, India's healthcare sector was about 160 billion US dollars in 2017. It was estimated to reach up to 372 billion US dollars by 2022. Now, as per RBC Capital Markets, approximately 30% of the world's data is generated by the healthcare industry. By 2025, the compound annual growth rate of data in healthcare will reach 36%. Now that is 6% faster than manufacturing, 10% faster than financial services, and 11% faster than media and entertainment. Now let's see the various applications and issues that analytics can solve in healthcare. We will look at drug discovery, staffing and operation, and see how analytics can help predict diseases. So talking about drug discovery. Now the drug discovery is a very long process. Sometimes it takes about 12 years and costs way too much, about 2.6 billion US dollars. Now, data analytics can increase the drug delivery process rate in medical science, helping to gain faster approval from the Food and Drug Administration. It can help optimize and improve the efficiency of clinical trials. Another key development that has happened in a number of pharmaceutical companies like AstraZeneca, Bayer, Clenzine, and Janssen Research and Development has recently announced a data sharing initiative called Project DataSphere. These companies have agreed to share historical cancer research data to help researchers in the fight against the disease today. The database will be available online globally, and the analytics technology would be provided by software vendor SAS. Now moving on, we have staffing and operation. Now this is another crucial problem that every staff manager in a hospital faces, that is the problem of staff allocations at a given period. Understanding how many people a manager should put on a staff at any given time period can be very challenging. If you put too many workers, the risk of having unnecessary labor costs go up. Too few workers, you can have poor customer service outcomes, which can be fatal for patients. So business analysts can use data to forecast patient admission trends at specific times of the day and provide insights to the staff managers to assign the right number of staff during peak and slow periods. Next, we'll talk about predicting diseases. So business analytics can also predict trends in the spread of illness, allowing doctors, hospitals, medical staff, and individuals to adequately prepare themselves. For example, in the case of coronavirus, analyzing data to predict future spikes in cases can help hospitals ensure the staff have enough protective equipment and patient beds. Using medical imaging and algorithms, physicians can detect diabetic retinopathy, which is a condition that damages the eye due to diabetes, and algorithms can also help detect cancer cells in a patient. Detecting cancer at an early stage has been a focus area in healthcare for quite some time now. The Cancer Moonshot Initiative by former US President Barack Obama, initiated in his second term, relies on advanced analytical techniques to pace up the discovery of cancer cures by identifying the trends and treatments used worldwide that have the highest success rate. Now, let's look at the hand washing case study in detail. So to give you some context, before the mid-19th century, the science of bacteria was not discovered yet. Nobody knew that microorganisms could spread diseases. Back then, even hospital staff did not follow basic hygiene practices. Not even doctors cared to wash their hands. Now, to be honest, we all realized the importance of hand washing after the world was hit by coronavirus pandemic. Now meet Dr. Ignaz Semmelweis. He was a Hungarian-born doctor and practiced at the Vienna General Hospital's maternity clinic between 1846 and 1849. Dr. Semmelweis is regarded as the father of infection control for discovering the medical benefits of hand washing. Dr. Semmelweis was very disturbed by the increasing fatality rate of mothers from childbed fever at Vienna Hospital. So childbed fever is also known as puerperal fever. It happens due to infections in the female reproductive tract following childbirth. This child fever was an issue of concern throughout Europe, with some hospitals having over 40% mortality rate. So out of every 100 mothers who used to give birth, at least 40 mothers would die in a week or 2 weeks' time. So the demo case study I'm going to present now concerns the work of Dr. Ignaz Semmelweis in reducing the risk of childbed fever during childbirth in Vienna Hospital during the mid-19th century. So he collected and analyzed historical data on deaths in his clinic and established a theory of what was contributing to increasing deaths of mothers. Now, to solve a problem, business analysts would often need to collect data from multiple sources. For this demo, we'll be using 3 datasets that are publicly accessible on Kaggle and GitHub. Let me go ahead and show you the 3 datasets first.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, so this is the first dataset that I have, which is called the yearly fever mortality dataset. So here you can see the first column is about year. It starts from 1784 and it goes till 1846. The next column we have is about the total number of births that took place at the Vienna General Hospital maternity clinic, and then we have the total number of deaths reported from childbed fever. Next, then we have the fever mortality per clinic. So in the Vienna Hospital, there were 2 separate clinics that operated between 1833 and 1846. Birth 1 column represents the total number of births that took place in clinic 1. Similarly, deaths 1 column represents the total number of deaths that took place in clinic 1 of the maternity clinic at Vienna General Hospital. Births 2 and deaths 2 has the information about the births and deaths that happened in clinic 2. Then we have our final dataset. This dataset is about monthly deaths, which starts from January 1841 till March 1849. We have the total number of births and the total number of deaths, and this monthly underscore deaths is only for clinic 1. We'll learn in detail about clinic 1 and clinic 2 at the maternity hospital and what they represent in detail. All right. Okay, so this is my Jupyter notebook, which has the lines of code already written. I'm going to explain you each cell of code and we'll explore the hand washing case study by looking at the outputs for each of the cells. Let's start with the first cell. So here I'm going to import my first data set, which is the yearly fever mortality. This is a CSV dataset, and to load the dataset, I'm using the pandas library and the read underscore CSV function. I'm using parse underscore dates equal to year. So this parse underscore dates will format the year column in the form of a date value. Next, I have set my index to be the year column. You can see here set underscore index equal to year, and I am mentioning that in place equal to true which means that the original data is now modified and updated in place. And I'm importing the data and storing it in a variable called yearly underscore deaths. Next, I'm going to print my data set. Let me just hit Shift Enter. We can see the result. There is an error here. It says, okay, this should be yearly underscore deaths. Let me run it again. There you go. So here you can see we have set the year column as our index. You can see the year column is our index. Then we have the other two columns, the total number of births and the total number of deaths starting from 1784 till 1846. All right. Now you can see the values for year, total births and the total number of deaths from 1784 till 1846 in the maternity clinic of Vienna Hospital where Semmelweis used to practice. Coming to the next cell of code, here we are going to calculate the mortality rate or the mortality percentage. For that, I'm going to create a new column called as mortality. So here I'm mentioning my data frame, which is yearly underscore deaths that we created above. And then within square brackets, I'm passing in my new column name, which is mortality. And the formula to calculate mortality is total deaths divided by the total number of births into 100. Now let's print the result. You can see here we have added a new column called mortality, and it has given us the mortality rate for each of the years starting from 1784 till 1846. Now next, we are going to find out some descriptive statistics using the describe function. So I've used yearly underscore deaths dot describe. If I run it, you can see the count, that is the total number of rows that are there in our dataset. Then we have the mean birth. So the average birth that has taken place in all these years per year is around 2268. The total deaths reported in each of the years, that is the average number of deaths, is around 93 and the mortality is around 3% or 3.3%. We have the standard deviation. We have the minimum value, that is the least births that took place in one of the years was 284 and the maximum is 4010. Then we have the 25th percentile, the 50th percentile and the 75th percentile. We are going to create our first plot, that is plot about yearly mortality rate each year between 1784 till 1846. Now here we are going to create a line plot, and for that I'm going to import my matplotlib.pyplot as plt. I'm setting my figure size to be 14,5 and using the plot function I'm going to create my line plot. I've given my data value as mortality rate. I'm going to use color as green and marker as O. So O will represent as dots. And after that, I'm going to give a title as mortality from childbed fever during childbirth. I've given a X label as year and Y label as mortality rate. Let's run and see the output. There you go. If I scroll down, you can see here we have a nice line chart. Now we can notice that the mortality rate started increasing somewhere around 1823. From here you can see a spike, and gradually the mortality rate or fatality rate from childbed fever started increasing from around 1823. The reason was, you can see here, there was a sharp increase after 1823. So the reason was, around 1823, Semmelweis clinic started giving lessons on pathological anatomy. So pathology, I guess you would know, is the branch of medicine that deals with the study of causes and effects of diseases. So doctors would take classes on the corpse's organs and tissues to learn the reasons for the cause of the death. So after the postmortems, then they might deliver a baby or examine a patient, possibly with pieces of contaminated flesh remaining in their hands. So Semmelweis suspected that this could be the reason for childbed fever. So he continued with his analysis and looked for further evidence to support his hypothesis. Now, till 1832, there was only one maternity clinic at the Vienna hospital. Now, that had become very overcrowded, so an extension was built and two clinics were created in 1833. You can see it here. Now, until 1840, both clinics were used for teaching and training medical students and midwives. So midwives are people who help mothers deliver babies and take care of newborns after childbirth. So after 1840, the physicians, that included doctors and medical students, used to operate in Clinic 1, and only midwives used to operate in Clinic 2 after 1840. So Semmelweis spotted that in Clinic 1, the fatality rate for mothers from childbed fever was 3 times more than those who delivered in Clinic 2. So you can see here in Clinic 1, which was the doctor's ward, and for people who were given trainings, the mortality rate was 10%, while in Clinic 2, where only the midwives operated, the mortality rate was 3%. So he again believed that in Clinic 1, where doctors and physicians operated, they also used to handle corpses during autopsies before operating on pregnant women. And they never used to wash their hands between the two jobs. But midwives in Clinic 2 never went to the autopsy room. So Semmelweis spotted that there were links between the lack of hygiene of the doctors and the mortality rate of the mothers. So let's analyze that data now. Cool. So I'm going to import my second data set, which has the information about births and deaths in Clinic 1 and Clinic 2. So here I'm importing my CSV data set and I'm storing it in a data frame name called clinics. Again, I've used parse underscore dates as year to format the date values. I've given my file location followed by the file name and dot the extension of the file, which is CSV file. Again, I've set my index to be the year column and I'm printing the head of the data frame now. Let me hit shift enter. Okay, so here you can see 1833 onwards, birth 1, death 1, that is for clinic 1. Then we have births 2, deaths 2 for clinic 2. Next, we are going to calculate the mortality for both the clinics, that is clinic 1 and clinic 2. So what I'm doing here is I'm creating two columns, mortality 1 and mortality 2. So mortality 1 is for clinic 1, then mortality 2 is for clinic 2. Again, the formula is the same. Deaths divided by births into 100 is the mortality rate. Let me run it. And now we are going to see the first 10 rows from our newly created data frame. You can see here we have added two more columns, mortality 1 and mortality 2. And these are the results. Now, if you notice, you can see the mortality rate for the clinic 1, where Dr. Semmelweis used to practice, or the physicians who also operated on the dead bodies used to practice. So the mortality rate is high there. Now let's compare and visualize the mortality rate at both the clinics. So here I'm again setting my figure size to be 14,5. I've used clinics.index mortality 1. I've given a label as clinic 1. Color I'm using as teal, marker is O. So this O will make sure for each of the years we have a dot or a round shape. Similarly for clinic 2 we have mortality 2. I'm using blue color, again marker as O. Then I'm giving a legend a title called mortality from childbed fever during childbirth. I also have a Y label called mortality rate. Let's run it. Now if I scroll down, you can see the mortality rate from 1833 onwards till 1846 for both the clinics. The teal color represents clinic 1 and the blue color represents clinic 2. So from this graph, we can see that the death rate at clinic 1 was significantly higher after 1840. You can see there is a huge spike compared to clinic 2, where only the midwives practiced and they never operated on the dead bodies in the autopsy room. So now Dr. Semmelweis had strong evidence to believe that the doctors were transmitting infectious flesh, or you can say material, substances from previous operations to mothers through their hands, and this was leading to childbed fever. So far, we have seen in our analysis till 1846, Dr. Semmelweis in mid 1847 asked his colleagues and fellow physicians at Maternity Clinic 1 to wash their hands with chlorinated lime solution before attending pregnant mothers, and the results were significant. So let's see the final analysis of Clinic 1 where Dr. Semmelweis practiced and how he was able to reduce the mortality rate. Now I'm going to load the monthly deaths dataset that has information from January 1841 till March 1849, and after 1849 his contract was terminated and he was asked to leave the Vienna hospital. I'll tell you why he was asked to leave a little later. Let's load the final dataset now. Okay, so I'm going to import my final dataset, which is the monthly underscore deaths.csv. I'm storing it in a variable called monthly underscore data. Let me run it. So here you can see the data for all the months starting from January 1841 till March 1849. Next, I'm going to find the monthly mortality at clinic 1. So I'm going to divide the deaths divided by births into 100. So here you can see we have created a new column called proportional underscore deaths that has the death rate for each of the months. Now the doctors in clinic 1 started washing their hands in June 1847 before carrying out delivery operations. So we have divided the original data into two data frames called before washing and then we have after washing. We will set the start of hand washing date to 1st of June 1847. You can see here I have said start of hand washing pandas dot to data frame. I am giving my hand washing start date, that is 1st of June 1847. For washing data frame will have all the values that lie prior to June 1847. So here I have subset my data. I am saying date should be less than our date, which is 1st of June 1847, and after washing should be greater than equal to 1st of June 1847. Run this. I'll print my before washing data frame. You can see it has taken all the values till May 1847, and for after washing we have all the values starting from June 1847 till we have March 1849. So we have split months data into before and after hand washing start date. Now let's plot our final graph that shows the difference in the mortality rate of mothers before and after hand washing. So here I'm setting AX, which is the axis for before washing. Dot plot will create a line plot. I'm saying X to be date, Y to be proportional deaths. I'm giving my label to be before hand washing. I'm using color as C, which is for cyan. Then here B represents blue. This is for after hand washing. Again, X should be date, Y should be proportional underscore deaths. Here I'm using a line style to be dotted lines to just, compare the plots. I've set my Y label to be proportion deaths. Let's run it and you can see the result. Let me scroll down. There you go. On the x-axis we have the date, on the y-axis we have the proportion deaths. The cyan color represents before hand washing, that is the solid line, and we have the dotted lines for after hand washing. Now you can see how starting from the summer of 1847, the proportion of deaths got reduced significantly, less than 5%, you can see here. So this was when Semmelweis made hand washing mandatory. Now we'll calculate the difference in average monthly percentage deaths before and after hand washing. So what I'm doing is I'm creating two variables, before proportion and after proportion. And then we are going to subtract the before proportion mean minus the after proportion mean. If you see the difference, you can see here it is 8.3%. So from 10%, we just reduced it to less than 3%. So this was all about the hand washing case study that Semmelweis had conducted using different data sets. So we performed this exploratory data analysis using 3 data sets, and we explored how using pandas and matplotlib you can create different charts and analyze data, yearly data or time series data. Now, the sad part is that with all this exploratory analysis and the findings Dr. Semmelweis made, his superiors at Vienna Hospital refused to accept his theory, and he was met with a lot of criticism. Medical community rejected his discovery in March 1849, and he was forced to leave the Vienna General Hospital. One reason we can argue as business analysts is that statistical analysis and data visualization were very uncommon those days in the field of medical science. Semmelweis only published his data as long tables of raw data, but he couldn't show any graphs or confidence intervals to support his hypothesis. His ideas were considered as offense to the medical community. He hurt them since Semmelweis meant that doctors were the cause of increased deaths. He believed in another theory called miasmus, which basically means some bad component in the air was the cause of childbed fever deaths. After 2 decades, when Joseph Lister and Louis Pasteur produced more evidence of the germ theory and antiseptic techniques, only then the value of hand washing was appreciated. But nevertheless, his work was based on evidence supported by numbers, showing that simple hand washing by healthcare workers could save millions of lives. Later, he did get some recognition. The Budapest University, where Dr. Ignaz Semmelweis used to teach after getting terminated from Vienna General Hospital, is now named as Semmelweis University. In January 2019, the statue of Dr. Semmelweis was unveiled at the World Health Organization by the current Director General, Mr. Tedros. You can see on the right. On the left, we have the State Secretary of the Ministry of Foreign Affairs and Trade from Hungary. On the 100th anniversary of his death, the government of Austria issued a postage stamp in his honor. And in March 2020, after the world was hit by coronavirus, Google also recognized Semmelweis' hand-washing findings and gave him a doodle. And that brings us to the end of our interesting video tutorial on Dr. Semmelweis' hand-washing case study using Python. I hope it was useful and informative. If you have any queries, please feel free to put them in the comment section of the video. Thank you for watching. Stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.